All right, so this is issue number 55 for the Kaiju Engine, where we're going to be setting up order independent transparency inside of Go, or sorry, inside of the Go game engine. So one thing I want to start off with is fixing an issue that I noticed while perusing the code in Win32.h, and this will be related once we create all these frame buffers and stuff. We want the window sizing and all of that to be correct. So let's go down to window main, and you'll see here, this is actually inverse. This is position and size. So position, we'll just do position size. Now the size is default size, which is not good. We want it to be the size we specified for the window. We never set that up for Windows, but we set it up for Linux. So we're going to say width and height for those two, which means we're going to need to pass them in. We'll pass them in after the window title. And that means that we'll have to do that for X11 as well. X11, when I was looking, has it just directly embedded in here, that 1280 by 720. Where'd it go? Here it is. So width and height, which means we need to go to where we call window main. We pass in a width and height. That means we need to pass it in here, width, height, and that's fine. This is probably going to need to be c.int. c.int. And then we need to do the same thing for our our X11 window. And then of course we need to go where we're calling this, which is going to be inside of the window.go. Oh, there it is. Create window. We're going to pass in w.width and w.height into there. Okay, and now I'm going to change this because on my laptop this is a little large, so I'm going to do 944 by 500. I think that's relatively similar aspect ratio. Cool. So let's just make sure that's still running correctly. Okay, cool. Looks like it's still running. This is offset from the center now because of the hard-coded numbers we did in main here. 1280 should be window host.window.width there. And that'll fix that. But anyways, we aren't going to do test font. We're going to do test OIT, where we're going to set up our framework or our test bed here for testing out an order independent transparency. And that's going to be similar to this one. Let's just copy this. And then we're going to add in different positions. We're going to say negative 0.75, 0.0, negative 0.75. And we can do negative 0.5, 0.0, negative 0.5. Then we can do 2525 and then 000. And we're going to need some colors. So we'll start off with some red, some blue combined. Then we'll do red, green, blue for our squares. Those are just going to be rectangles. We're not going to have any rotations, so let's get rid of that. And we're going to change this to the length of positions. Okay, we can bring out our shader, our mesh, and our texture outside of the loop. We were just testing to make sure the caching was working there. And basic vert is fine. Quad mesh is fine. Textures, I'm going to change this to square. It's just going to be a white square because this shader calls for a texture, so we're just going to supply one. Okay, I'm going to change this to test, test basic shader data. set our colors, get our transforms. We're going to set our transforms. And one of the things we're going to add in here is UseBlending is going to be equal to colors I.A is less than 1.0. So we need to tell the system if this if this drawing should use blending. And if it does, it's going to go through the transparency accumulation pass, the accumulation reveal pass for our FBO. And then if it's not, it's going to go through our solid pass. Those are passes that we do to accumulate the values for order independent transparency using a particular algorithm that you can commonly find online pretty simplistically. And the reason we're doing this is because when we render, typically we need to do a sort order for blending, because if you draw a solid and then a transparent behind it and then a solid behind that, you'll get some weird clipping where the transparent will block out everything behind it because of the depth buffer. So uh, sometimes what some people will do is they'll sort everything visible by the camera when it's drawing to draw closest to the camera to the furthest. And that's just a lot of math we don't want to do. We don't know how many objects there are. There could be thousands, tens of thousands, hundreds of thousands of objects there. So just doing a render pass, a few render passes to accumulate the values and then mix them inside of a final composition is just makes our life a lot easier. We don't have to deal with all that sorting stuff. Okay, and then we call our test. So we're going to add this blending into here, use blending bool. And of course, we can't draw blended and non-blended together inside of a grouping. So we want to add into this check dg.useBlending is equal to the drawing useBlending is equal to g. G is an instance data group. UseBlending. Where did I put it? Oh, I put it in the drawing. Yeah, that's fine. I put it in the drawing, and then I need to put it inside of the group UseBlending there. Yeah. So if the blendings match, then the group matches. Otherwise, it's going to be a new group. And so all the blended ones are going to draw, and all the solid ones are going to draw separately. So what I'm going to do right now is pull over some shaders and other files, namely the square texture file, and then we'll go over what the shaders are so that when we drop in the code, it'll make a little bit more sense. Okay, so I've brought in the square content, which is just a white square. It doesn't need to be that big, but whatever. And then I have a hdr.frag, hdr.vert. These are just going to be for after we compose all of the images, we're going to then render the frame buffer onto a rectangle that is going to fill the screen. And that's what this guy is going to be. But I'm actually going to modify this a little bit. I'm going to get rid of that, and I'm going to get rid of that. And we're going to change this to be consistent with our other shader code. Okay. And then the frag, we're just going to leave it as it is. So the HDR vert is just taking a rectangle and drawing it to whatever the positions are. In this case, it's going to be the full window. And then the fragment, it just says if HDR is enabled, we're going to do this math stuff. I haven't really messed with this in a while. We're going to have it off as default. We can deal with that later. Otherwise, it's just going to plop in the color, which is really all that's going to happen is just plopping in the color from the frame buffers. And that's basically it for those. So the next ones are the OIT composite. You'll notice it has the same exact code we just did, minus the UV coordinates. And you'll notice it's using version 300 ES, and this is the version we're going to use in the other ones as well for compatibility. So let's go to our basic, and let's paste that in there, and let's paste that in there. Okay. So, oh, it requires me to define the precision, blah, 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 blah. Okay, I'll put it in there too okay. So we set up this to just fill the screen. Now this is the composition code. You can find this online. Essentially, you get an accumulation texture and a reveal texture. And the accumulation is, I believe, the color, and then the reveal is a red channel texture, which tells you how much transparency essentially this thing should be, is distance. So we can combine those two with our solid pass, which is just a traditional regular render we've been doing. We combine these with the solid pass to create our final image. Um, and so this is the color from the transparent. This is how much it's revealed, if it's revealed at all, because the solid pass could be blocking it. We're using the depth buffer from the solid pass. So you have to do the solid pass first to set the depth buffer. And then you can do this other one so it can determine how much revealage, as it's called, it needs. Just some helper functions. And then very basic, like I said, merging those two with the solid pass. So one of the things we're going to do is we're going to be using basic frag. You'll notice it just pumps the color straight through. But if you're noticing in our text.frag, we have an if define OIT, order independent transparency here. And this is just so we don't have to write multiple shaders. We can just have this built straight in as first party. We can always change this later, but essentially we want to create this unweighted color, which is going to be equal to this. And then we want to do this block. And out color is going to become frag color. There we go. And in the solid pass, if we have transparency, we just discard that guy. 1 minus 0.01. That's an interesting way. I don't know why I did that, but it's there. I'm not going to mess with it. So that gives us this if define OIT. And this is going to be important for later, that it's exactly this string. Because obviously we don't have a define OIT up here. So that means it's always off, until we do a little bit of magic later. We're going to inject that into the source code. And when we're in Vulkan, we're actually going to inject in a source code, but do a separate compile for it. Actually, you can set the defines in the SpearV compile. So we're gonna compile it once, and then we're gonna compile again with a define with OIT, so we have the two versions. But that's only if OIT exists. Although we may do it to all of them, and then OIT just doesn't exist, so it won't happen. So yeah, there's a couple things for future reference with Vulkan and all that other stuff. So since we added these new shaders, we're going to go to the config of the assets, and we're going to add in our new buddies here. I'm just going to copy and paste that stuff in. So now that we have all that set, we're ready to begin using those guys. I'm going to try to save these. I keep getting these. Oh, it's read only. Override it. Why is it read only? Okay. Okay, and this OIT code is going to be a little long-winded and repetitive, so I'm probably just going to work it out and go over what I've done, what I was thinking about. Duck-go. So first we're going to set up the frame buffers and textures that we need inside of the GL renderer. And yeah, I'll just do that real quick. Okay, so you'll notice that I have a texture here. What I'm going to do is I'm actually just going to say type texture is equal to handle, just so we can use that a little later. We're probably not going to mess with it right now. That's just some cleanup stuff for later. So we've got the opaque frame buffer, the transparent accumulation frame buffer, the transparent reveal frame buffer, the opaque texture, the depth texture, the accumulation texture, the reveal texture, the reveal accumulation texture, and the reveal texture. These two down here, we're not really going to need those handles in Vulkan. We're going to do it a little bit differently, but for OpenGL's sake, we kind of need those guys. So we're going to throw that in. Okay, I don't need an RBO. Then we're going to have our color buffer, our composite shader, our HDR shader. Those should be self-evident based on what we just talked about. And then our compose quad. This is just the quad that we're going to use to render our frame buffer textures onto for other frame buffers or for the final render. This is that HDR. It's going to be set to 0, so HDR is going to be disabled, and so exposure doesn't matter, but we can fill those out as needed later on, probably configure them, but I'm putting them here as stubs for now. So the next thing we need to do is initialize this stuff. Func rgl renderer. I swear this thing's listening to me. Initialize. And we're going to need the caches, render caches, and a width and a height. Specifically in 32 because we're going to be communicating with OpenGL here. So we'll start with r.setup OIT frame buffer, and this is a function we will make in just a moment. And then r.compose quad is going to be equal to new mesh unit quad is fine enough, thank you. And then this thing needs the caches.mesh cache. r.composite shader is going to be equal to dot shader. Okay, and then we're going to pass in assets. Let's do this on a new line. Dot shader vert OIT composite and asset shader frag composite, and then nothing for geometry tessellation, controller tessellation, evaluation. r.hdr shader is going to be equal to the shader assets.hdr vert and frag and blank for those other ones. Cool. I'll do that on a new line too, just to make it even. So now I'm going to set up this. I'm going to make a new file, renderer underscore oit.gl.go. And we're going to have the same build guard here. Package, rendering. Okay, I'm going to fill this out real quick and then we can go over it because this is a lot of repetitive stuff. Okay, so we got all this stuff set in. I do need to go and create a lot of these fields in the C wrapper functions, and that's also mundane because if you've been watching up till now in the playlist, then you know that how this is basically going to go. So it's a bit of a grind. I'll be right back again. Okay, I'm not going to go over all the things I pasted here. For the most part, they all just funnel straight to C code, so there's no point in wasting our time looking over that. One of the main things I want to do before I continue is I want to call initialize on the renderer now that we have that function. And we may move this into a different place later. Initialize, but that also means we need to actually pass in, we need to actually make this into a part of the interface. So go to renderer, and initialize. And then what did we initialize with? Renderer. Find this. Copy that and paste it there. So now in our main, okay, main's happy. All right, back to where we were. Going over this stuff. Let's check out these error first. r.draw, this is a function we haven't made yet, so that's all those are. I guess we'll fill that out real quick. So we need a draw, render. Yeah, we have a big draw function, but now we need a little draw function. Draw. And the reason we need this is because we're going to call draw multiple times. One for the solid pass and two for the transparency pass, which is basically going to be this block here minus the clears. Okay, this is the problem with recording and hitting pause to do things is I went through and I explained this entire thing here and realized I paused it instead of recording it. So I think where I left off was I cut that and I pasted that guy up here, and then I got rid of those clears there. So here we go, round 2 for me, round 1 for you. Okay, so here instead of the OIT, we have the setup OIT frame buffer, which is going to go and set up all the frame buffers and textures that make up our order independent transparency. So first we delete all of the existing ones. Let's say if we're remaking it due to the width and height changing. So you change the window size and we need to recreate this or for any other reason. Then we set up our opaque texture. This is where we're going to draw our solid objects. You'll notice that everything is going to be floats here just so that our math can be much more accurate when we're trying to lay things on top of each other and work out distances. That's the texture for that. We have a depth texture, pretty standard, depth component 32F. We have the opaque frame buffer. This is the frame buffer we're gonna be binding in order to draw our texture and capture our depth of those solid passes. Throw if there's an error, unbind. Then we create an accumulation texture. This is where we're going to get the color values from the transparency, the blended render. So we're going to apply those in there, and then we have the reveal texture. This one is the red color channel, R32F, and it tells you the depth essentially. And you'll see later, but we're going to disable depth on the transparency pass, enable it on the solid pass, and that depth is going to automatically clip things that we need to clip. Then we have the accumulation FBO, same thing. Bind those two textures together, and we are going to render them. Now, the accumulation texture is attachment 0, and the reveal texture is attachment 1. We have two color attachments because we're drawing two color images. One is all red, of course. And so bind those two, if errors throw, and then we're going to do the reveal accumulation. And this is just so that we can accumulate everything that has gone on, those two bound together. So same kind of deal here. Bind those two color attachments, and then unbind. Now we aren't going to have this second one here in Vulkan, so I just need it in OpenGL. It might be because I made a mistake, but c'est la vie. You can always refactor. Well, now we're going to take a look at the solid pass. This is solid only objects, no transparent objects. Essentially everything that is set to not use blending. We're going to enable the depth. It's going to be less depth mask, and we're going to disable blending because this is a solid pass. Clear out the background color, bind the opaque, clear the color buffer, depth buffer, and then draw. Solid pass, pretty straightforward. Transparency pass is going to have two passes. First one, turn off the depth, enable the blend. Here's the blend function, there's the blend equation. This is the frame buffer we're going to do, is transparent accumulation. We're going to set these two for our color component 0 and 1, and we're going to draw. Then we're going to change the blend function, 0 and 1 minus source color. Transparent reveal FBO is going to be bound, and then we're going to do that drawing. Lastly, the compose pass, where we take everything and combine it together. So we're going to use the composite shader, the compose quad, turn on the depth function, enable the blend. Here's the blend function. We're going to bind to the opaque FBO. So we're going to reuse that color FBO that we originally rendered to, and we're going to just draw on top of it. So we're going to use this. We're going to use the program that we set, composite shader. And the first texture is going to be the accumulation texture. So this is the transparency colors. The second one is going to be the reveal. That's that red channel to tell us the depth of this object and whether it should be revealed or not. Then we're just going to draw the quad out to that opaque FBO. Okay, so I think I did that one a little bit faster because I already knew what I was going to talk about because I already did it once. And just to be sure, let's go back to drawing.go. Let's check out, let's see, I know that I matched these two, the blend, but I don't think I assigned it down here. So we need group.useBlending is drawing useblending. And this one doesn't need to be public, so we'll lowercase that. As you can see, it let me lowercase it because we're not using it publicly. Okay, good thing I caught that. We're gonna need it. Now for the drawing portion. I'm going to write this out. It's pretty straightforward. I'm just going to separate the solids from the transparents. Okay, so we have our solids shader draw array, our transparent shader draw array, and this is probably a good place to optimize later if it's proving to be a bottleneck with how much stuff we're drawing. We're going to go through our drawings, set up our new shader for, this is solid shader, our shader solid, shader transparent. If we have a subshader, we're going to use the subshader. Otherwise, we're going to just use the shader as it exists as a fallback. This is technically a problem, so we might make something magenta or something like that there. Something to look at later. Then we have our instance groups, and we're going through them. And if it has blending, it goes to transparent. If it doesn't, it goes to the other. And it's very straightforward. Then just add them to the solids if they exist. And this, I don't think I actually have to do this if statement. I think the append will just not do anything if the slice is 0. Special case is legal for appending a string to byte slice, so that's different. Append built-in function elements to the end of the slice if it has a sufficient capacity of the destination to accommodate the new elements. If it does not, the underlying array will be reallocated. Append returns the updated slice, and therefore is necessary to store the results with the pen, often the variable holding it. So it doesn't really say. So I'm assuming it does, but we don't need to test that out. Also, while I was reading that, I realized that I do use slices a lot, and I return pointers to things from them, which is probably a no-no. So that's something I'll have to review a little bit later, is where I use my slices, where I pass back those pointers to those, and make sure that they're not, being reallocated and moved. I'm not holding on to that pointer for a long period of time. Usually, I'm pretty fastidious about that. I don't really believe in just hacking, just throwing in an unperformant code in all cases just because you want to cover one flaw. But that is something to kind of review anytime a slice is added and it's not a slice of pointers. So I will have to go through my slices and review that. Or if somebody wants to audit it as well, be my guest. Any help would be appreciated. The last thing I need to do is actually make the swap frame. We do have some swap code. Main swap. Nope, it's inside of render swap buffers. We do have the swap buffers, which doesn't really do anything. What I want to do is before we swap the buffers, we call window renderer dot swap frame, and we'll pass in the width and height into that as in at 32. So I want to add this to the renderer interface here, which means we need to add it into our, why is this red? Because I don't implement that anymore. And we don't have a width and height. We need to say w.width and w.height. Cool. And now we need to implement that function. Voila, magic, it's implemented. Pretty straightforward. We do the compose pass. We compose everything. This is that compose function we had before. Then we disable the depth mask true. I might re-review that. Disable the blend, unbind the frame buffer. Unbind the frame buffer. Does the compose pass not do that? Unbind vertex, unbind buffer. No, it doesn't. Okay, well, probably I'll move that. We update our viewport. This technically we don't have to do all the time, but whatever. We set our clear color to this nice, pretty magenta, I believe that is. Then we have, we're clearing out all these 3 components, or what are these called? Clearing out all these, I don't know, whatever these are. Then we get the ID for our HDR shader, which we talked about. We use it. We create that compose quad. We're just reusing that. It's going to be the same kind of render. We fill out these fields if needed, and then we just bind the textures and let it go off and do its own thing. And that will render out how we need it to render out. Now, you may be asking, hey, what about that sub shader? We didn't actually set that. That's always null. You are correct. One thing I want to do is this will be an infinite loop if we call it delete. And it's just going to create subshaders on top of subshaders the way I'm going to do this. So I'm just going to paste that in here, renderer, and we're going to create shader, and we're going to do S subshader and asset database. And just for good measure, because it will come in here twice, but it won't create a new shader. It'll just, this is a to-do. Sorry, this kind of stuff just lives in my head where I foresee problems often, either because it's happened to me before or whatever. But this is going to be a point of refactor. So I'm going to say to do make this not needed. s.subshader.subshader is equal to no. We don't need a subshader. And this should probably be called OIT shader because that's how it's being used right now. But some things should be prolonged in order not to spend a lot of our time going down too many rabbit holes. I'm trying to keep some things a little concise. Okay, basic.frag. So you'll notice that we need to define this OIT. So let's add in a defines here to tell us what we need to define in the shader. And I'm going to do a to-do of this is only for GL. And this shader is not GL only, so might need to do something there. And then let's create that so that it's not going to complain at us when we go to append stuff to it. Okay, so let's go back to renderer GL. And let's go to where we create the shader, create shader object. Okay, so this is where we're going to say if the length of defines, we're going to have to pass that in, is greater than 0. Let's pass in defines here, defines string. Okay, if we have some defines, we're going to say define string is equal to version 300 ES. This is kind of hacky, but so is all of code. Point of fixing later. It's also why I make these videos, so everyone can see my laziness, I guess, and call me out on it. Strings join, defines, yeah. And then the source is going to be equal to strings.replace src version 300 ES define string and 1. So we're just going to look, oh, this should be a space, I think. Yeah, so we're going to look for version 300 ES, this guy right here. I even copy and paste it just to make sure I'm doing this right. And we're going to replace it with itself because we add it here, add a new line, and then we do all the defines one after another. So that will modify the shader code to push in defines. The next thing I want to do is I want to return the source code here because we're going to need to do some other hacky stuff to get this working that we need to clean up later. src. Essentially, we need to know when we construct this object if what the source code was so that we can create the subshader if we find an OIT, which shouldn't be in this function, but this is where we're going to put it because it's going to need a little bit of cleanup. Frag src. And we're going to pass in no def is equal to blank string. Let's just do that one. No difference, but that's the one I want. Put these here, and then of course we're going to pass in shader.defines into that one. And the fragment one, that's the one with the OIT. Pretty hacky stuff. I don't like this, but I want to get OIT working, and then we can, again, come back and clean this up. Okay, so now after this, we're going to need to determine if we need to do OIT. Const def equals define OIT. So if there is a define, it's going to be const if def equals if defined OIT, if not strings that contains frag src def, because we don't want an infinite loop here, not strings that, and this one's going to be strings that contains frag if def. And we're going to say shader.subshader is equal to new shader And yep, it's going to be all those guys. Eval path. Oh, I guess I did need the renderer in there, which is, we're going to make this a pointer. Okay. Shader.subshader.defines. Again, this is a prime location to refactor. If anyone's feeling up to the challenge, help me out here. But for now, we need to get things working and games running, and then we can make things beautiful as we go. I do try to make it so that it is somewhat flexible to refactor later. So I try to make the depth of this nonsense a little shallow. So with that, I think, is that all of it? Let's build and find out. Got an error, undefined variable reveal instead of our fragment shader. Reveal. Oh, we gotta actually put our outputs here. So let's just copy those from text frag. These two guys, and just, I have them before the sampler, so put it right there before the sampler. Okay, that should make it happy. Sweet. Now we've got our 4 panels with no transparency. Let's go check out main. At least the 4 panels, Drew. Test OIT, color. All of them have no transparency. Let's make the back one transparent, and then the 2 front ones transparent, and the red one is not going to be transparent. It's going to be solid. So there we go. We have our transparencies here, and this one is transparent, but it's obscured by the red one. Cool. And the order of these is just kind of plopped in there. So that looks about right to me. One thing we can do is check out render doc. So I was saying we'll check it out in render doc. I can't believe I did this twice in one video, but I explained the whole render doc thing and wasn't recording. I need to get better at that. Anyways, it's not that much. We can go over it. So we'll launch this in render doc. Oh, one thing I did point out when I was going through this is if anybody knows how to make Visual Studio Code not compile as like this random number string for my workspace, that would be great. This annoys me. Anyways, well, what is that? I might have to save this capture or something, bro. Well, I don't want to debug this stuff right now. Maybe it was fine. It's just some kind of bug between these 2 phases. I don't know what happened there. Let's relaunch and get a regular capture. Come back to that stuff. Okay, regular. What? Did it again? Hold on. Okay, we're just going to leave it. I think it's something with render doc because obviously when it's running, it doesn't do that. But when it goes to take a picture, it trips up. So let's just ignore these random blocks for now. Let's go through. You'll see these 2 passes here. These are our transparency passes. This is our solid pass. So notice we have our red here for a solid and its depth here. So this is our solid output, and this is our instance data, our model matrix right here, and our color red. Then we come into the transparent pass, which has an instance data here for all the instances. And this is going to be our output. You'll notice that it uses that depth buffer to cut into this magenta one, this pink one here. Boop, cuts it right out, but the green and the blue are fine, and you'll see green doesn't adopt anything from behind it. So that's all working out. And then we're going to check out our revealage here, and you'll see that this is how it's revealing what it looks like with that red channel revealage. We'll go to the next pass, which just changes out kind of how this red revealage works with a depth pass. So the more importantly, we're going to go over here to where we create our image to be rendered You'll notice we have our accumulation pass, which is our accumulated color. We have our revealage pass, and we're drawing on top of the opaque buffer. So see, this is fine here. Yeah, we're drawing on top of the opaque buffer, so that's why the red block is in there automatically. So it just does that blending. And we take that and then we turn it into a HDR image, so this is the HDR buffer, and we output it to the window. And hey, would you look at that? The weird fragmentation went away. I guess it was just a random bug inside of RenderDoc. So that's basically what we're looking at here for how those buffers work and work together and combine, just for the sake of understanding, and you're seeing the flow of the process. So if somebody wants to come in, do a refactor, do some cleanup or whatever, it makes some sense on how this order independent transparency was set up. So thanks. I think in the next one, I'm going to work on some basic UI stuff, or soon I'll be working on some basic UI stuff. I also need to set up stylus input, touch input, controller input, those various inputs. So yeah, cool.